Nhìn thấy rõ không ta? Thấy bảng nhưng mà nhìn được không các bạn? Giờ sao ta? Nhưng mà thôi để cô dạy hôm nay một tí đi để, chứ không thì hay là mấy bạn đợi cô bỏ đi cái giới hạn 40 phút rồi là học mình sẽ kết thúc hơi muộn chút nha các bạn. Để cô dạy hôm nay xong rồi tính tiếp, chứ bây giờ cứ làm tới làm lui rồi mất thời gian quá. Ok, để cô sẽ chuẩn bị cho cái bữa sau, tại bữa này trường mình người ta chưa có chuẩn bị link, chuẩn bị lớp học nên là cô phải tự làm hết. Thôi để cô bắt đầu bài giảng nha các bạn. Rồi các bạn là thấy video này kia ok hết rồi phải không? Cô thấy bản nhìn ok rồi. Nãy giờ bao nhiêu phút rồi không biết nữa. Nói lại lần nữa nha các bạn. Sorry. Okay. For stationery, everyone, look at the stationery. If you want to check the stationery, so you must consider the plots in the plots have no growth or backlights. I will give you example. So for the data, the mean and the variance must be constant. So that is the stationary. So you can see here. That is the non-stationary. Is this because and okay. So look at this. So for non-stationary, is we also to look at bigger and slow. So here several significant deadline. That is the one class is close to zero, and the rest that is nearly equal to zero. So another signal, so you can know that is your data is not stationary. So if your data is not stationary, non-stationary, so you must to remove them. So how can we remove that? Remove non-stationary, we take the difference. So the difference here, that is different between yt and yt minus 1. So you can take the first difference, but your data is still non-stationary, so you can take the second. So it's in the practice, it's not over than the second difference. So your data become stationary. Okay. So you look at this. For remove non-stationary, remove it. That is non-stationary, right? The original is non-stationary. So after we take the first difference, so the data look like this, non-stationary. Become stationary. From non-stationary, we take different become stationary. So you see the mean and the variance is constant. So, but obviously you look at the plots, it's no growth or decline. Here you see no growth or decline. And after you take the first one, so you can see that you look at the ACF, just only one that is outside of the limitation, 5%. See, just like one. So it's satisfied. So if you look at the partial autocorrelation, just only 1 plus 1 is outside of limitation. It's satisfied 5% significant limits. So, okay. Why I need to review your for you for stationary and non-stationary, because that is related with ARIMA. So ARIMA model. So let me review. So we have several models, right? that represent for P, that is Q, that is PQ, that is PDQ, right? So for mixed model here, your data must be stationary. So for ARIMA, you can use when your data is non-stationary. So it means D can be equal 0, D equal 1, and D equal 2. If D equals 0, that is already non-stationary. That is stationary. So D equal 1, non-stationary, but you take the first difference. And here you take the second. So if D equal to 0, ARIMA becomes mixed model, right? Mixed model. Here that is a mixed model. Okay, everyone. Non-stationary. Any question? If no questions, so I move to the random walk. You remember random walk? So why we need to review random walk? Because random walk is this model is widely used for non-stationary data. So random walk. Why we say that random walk? You remember? Because that is the white noise. The white noise is random, right? So the difference here represent for one set, right? If I write like that, oh. Còn 10 phút nữa là hết giờ nha các bạn. Trước khi còn 5 phút cô sẽ làm lại. You see, that is the difference between t and t minus 1. That is like a step. This one will be the random. The y now is random. So that's why we call that the random walk. Random walk is used for non-stationary data. So of course it's random walk here. So right now I move to the right side. So we can write like that. So the random walk, the trend or down suddenly because that is random. That's belong to why now here. Okay. So and I just tell you, would you should take the first for remove and the second. So let me do the different the first difference. So for example, if you have the first difference like this, right? So what about for the second? So the second difference should be equal what? Right? So we can substitute in here. So what you can see? So you will have, you substitute, that's what? Minus t plus 1. And the same, this one will be equal what? Yt minus 1 minus yt minus 2. This is. So minus t minus 1. So you have 2 yt minus 1, right? So you can look at the slide so you can see here. That is the first second, because in the practice, so we just focus on in the practice the second. So next, we consider what the seasonal difference. Why we consider seasonal difference? Because for seasonal data, so should be not stationary. Also, the stationary, seasonal, stationary. So, okay, so we go with the seasonal. So the first that is the random walk, right? And another that is the seasonal. Seasonal data is non-stationary. So we consider seasonal. Seasonal data is non-stationary, so we also take different. For that one, we take difference to remove non-stationary. So for that one, we take the difference here. Look at this. See here that is t minus s. S is the length of the season. S, that is the length of the season. So for example, S equals 12. So you have 12, 24, 36. That is the season. Okay. So if you look at that, that is the non-stationary seasonal, right? Non-stationary but seasonal. So after you take the difference, so you can see that your data is closer to stationary. Here is around more than 5%, more than 5%. So around just a little bit more than 5% outside of limitation. And autocorrelation show that the gradual decline. So here that is close to stationary. It's not stationary, just close. So in here you see that 1, 2, 3, 4, 5. So it's several flat here that is the outside of the difference, the seasonal difference. So, and this one, so we still can do the second difference to make sure that it is stationary. Okay. Okay. So for seasonal difference, you also do the first and the second is okay. So we have the seasonal and random to check the difference. So right now we test for stationary. That is, you look at the data, you look at the plots, so you can recognize that your data is non-stationary or not. But you still have the several statistical tests. So to know that is your data is non-stationary or stationary. So we have the Dickey-Fuller test. So in here, the easy way we have like also unit rule test, and Dickey-Fuller test. So okay, for test for stationary, so you can look at the that is the regression. You look at the regression here. Look at the regression. Look at the regression. So what they tell you that